So let's get a definition for a vertical asymptote. If this rational function is not defined at x equals c, because x minus c is a factor of f of x. Nope, not f of x, q of x. It's a factor of the denominator. Sorry about that. Then x equals c is called a vertical asymptote. A vertical asymptote. Okay, so name the vertical asymptote for each rational function. Well, it's anything that makes the denominator 0. We played this game with these four already. The thing I can't use here is x equals -5. So when I graph it, I would go to -5, and I would have a vertical asymptote, right? For this one, x equals 2, and x equals -2. So if I was sketching a graph of that one, I would go to x equals 2, and I would also go to -2, and I would have two vertical asymptotes. For this one, there is none. And for this one, it's x equals -2. However, is it? Because that factors x plus 2 and x minus 2, and things will cancel. We'll get back to that later on in the show. Graphing transformations of the parent functions. Okay, so look, this is like y equals 1 over x. But when I add 4 to where the x is, we go left 4 units. So if I go left 4 units, I can either think of taking the vertical asymptote and moving left 4, or you can just look at this and go, I can't use -4, so -4 is my vertical asymptote. So I go 1, 2, 3, I go left 4, and I put a vertical asymptote at x equals -4. Think of it as the number that you can't put into the denominator, or think of it as the parent function being moved left 4. Either way is fine with me. Now, I can't get y equals 0 for the same reasons as before. And so this graph is the same as the parent graph. It's just been moved 4 units to the left. Okay, the vertical asymptote is x equals -4. Now, this next one is like y equals 1 over x squared. So it has a vertical asymptote at x equals 0, and it has a horizontal asymptote at y equals 0. But look what happens. We go right 3, and we go up 2. Now, if I take a vertical asymptote at x equals 0 and I go right 3, aren't I going to be at x equals 3? And isn't that the number you can't put in there? So I'm going to go 1, 2, 3 units over, and I'm going to put my vertical asymptote at x equals 3. Okay, then I would have, like over here, a y equals 0, but I've got to move everything up 2. So if I'm going up 2, I will have a horizontal asymptote at y equals 2. And then what happens from there? It behaves exactly like y equals 1 over x squared. Both of them go up. Next page.